So have you ever watched a pro play GeoGuessr? It's
Yeah.
it's honestly humbling to watch.
Oh, it's incredible.
They get dropped on some random dirt road, they spot like a specific type of fence post.
And suddenly they know they're in, rural Estonia.
Exactly.
But the really top tier players, they do something else too. They don't just go on vibes or intuition.
Mm-hmm.
If they see a sign, they want to cross-reference it on a map.
They verify.
They verify to confirm the road layout actually matches what they're seeing.
Right, and that's the gap we're diving into today. The paper is called Thinking with Map,
Mhm.
and it tackles this massive limitation in AI vision models. The fact that until now, AI has basically been playing GeoGuess purely from memory without being able to, check the map.
That's a great way to frame it. The paper from GeoGaLegs, it points out that the existing large vision language models,
Like GPT-4 or Gemini?
exactly, they hallucinate so heavily in these tasks. They see a tower and think Paris, completely ignoring that the street signs are in Chinese.
Because they're just trapped in their own weights. They can't step out and check against reality.
Right. So the mission here was to build an agent that stops guessing and starts acting more like a detective, an agent with actual tools.
They call it the agent in the map loop.
Yep. So instead of just spitting out a coordinate, the model gets access to APIs. It can do keyword searches, look up specific points of interest POIs, and query map data.
But this isn't just give the AI internet access, is it? It's way more structured. That Xiamen example in the paper really made it click for me.
The Seikonomi bar case.
That's the one. So the AI looks at this street view image and it extracts the text Seikonomi bar from a sign.
And a standard model would just guess Japan because of the language.
Right, of course. But this agent runs a search query for that specific name and finds a candidate location in Xiamen, China.
But, and this is the critical part, it doesn't just trust that search result.
No, it looks back at the image and sees a Louis convenience store next door.
So it queries the map data again. Is there a Louis convenience store next to this specific Seikonomi bar in Xiamen?
It's looking for spatial consistency. It's
It-
verifying the visual evidence against the ground truth map data.
Precisely. It's reasoning, not just pattern matching. And to get it to do this, they used reinforcement learning. They rewarded the agent for using these tools efficiently to narrow down the search.
Okay, there's another layer here that I think is crucial, this parallel test time scaling. It sounds a bit dense, but it's basically how the model handles uncertainty, isn't it?
It is. Think of it like a chess computer exploring different future moves at the same time.
So instead of just one chain of thought, I see a sign, I'll search it, I'm done.
Exactly. It generates multiple reasoning paths all at once, in parallel.
So maybe path A focuses on the shop sign, but path B focuses on the road intersection layout.
Exactly right. It explores these different possibilities and then uses a verifier to sort of vote on which path led to the most logical and consistent result. It mimics how we eliminate possibilities.
But to prove this works, they couldn't just use standard data sets. We all know models like Gemini have already memorized the Eiffel Tower.
That's the data contamination problem in a nutshell. If the answer is already in your training data, it's not reasoning, it's just remembering.
So they built their own map bench.
Yeah, and it's a data set focused on dynamic, urban environments in China, which is smart because those places change so fast. It forces the model to rely on live data, not old memories.
And the results were, well, they were stark.
Oh, completely. When they compared their method against the closed-source giants like Gemini 3 Pro,
Even when Gemini had Google search access.
even then, this new method just crushed it.
I have the numbers here. On fine-grained accuracy, so pinpointing a location within 500 meters, they jumped from about 8% to over 22%.
Yeah. In computer vision, a 14% jump isn't an iteration. That's a generational leap.
Yeah.
It just proves that a smaller model with the right tools can outperform a massive model trying to brute force the answer.
It really shifts the paradigm from AI as an encyclopedia
To AI as a researcher, an AI that knows how to find and verify things.
But that capability brings us to a more provocative thought to end on.
I think I know where you're going with this. Privacy.
If an AI can take a grainy background detail from a selfie, a partial sign, a curve in the road, and use live APIs to triangulate the location within a few hundred meters, then security through obscurity is officially dead.
It really is. We used to think that unless there's a major landmark in the photo, you're anonymous. But now machines can read the spatial signature of our world better than we can.
It's a sobering thought for the next time you post a photo. Thanks for deep diving with us.